Lesson 2-3, graphs that enlighten and graphs that deceive. Objective, develop an ability to graph data using a dot plot, a stem plot, time series graph, Pareto chart, pie chart, and frequency polygram. The second objective is to determine when a graph is deceptive through the use of a non-zero axis or a pictograph that uses an object of area or volume for one-dimensional data. Graphs that enlighten. Dot plot, a graph of quantitative data in which each data value is plotted as a point or dot above a horizontal scale of values. Dots representing each values are stacked. Features displays the shape of the distribution of the data. It is usually possible to recreate the original list of data values. So let's go to our calculator here, and I put some stuff already in there, so that make it kind of easy. I went ahead and put this data in there, and we're going to do a scatter plot. So once you get your data in, you press on, and the graph, and let's see here, mail. And you'll notice it defaults to a plot graph there. Okay, so that's how you do, and you can just kind of copy it off your calculator. Your next one, stem plot, stem and leaf plot, a graph of quantitative data by separating each value into two parts. The stem, the leftmost digit, and the leaf, the rightmost digit. Features, show the shape of the distribution of data, retains the original data values. The data are sorted or arranged in order. And I'll show you how to do one of these. So here we go. You got your stem is on the left side, and your leaf is on the right side. You need to find your smallest number, and that's 42, and your largest number happens to be right next to it, 96. So we're going to have 40, 50, 60, 70, 80, and 90. So 42 is the smallest number, and 96 is the largest number. We'll go ahead and get those out of the way. All right, so what do we got here? We got 84, 72, and 72. So we got those. We got 74, 60, and 64. We got a couple of those. 50, 64, and 72. So I'm going to put that 4 there and put a 2 here. 50, 64, and 72. You got 60, 78, and 72. So I'm going to put a 4 here, make that a 2, and an 8. Probably a good idea to do this with a pencil. 52, and then 82, and then 54. 62, I'll put a 4 here and put a 6, 2 there, 62, 66 and 66, 6 and 6, 52, so let's put a 4 there and put a 2 here, and 66, and 56. 76 and 80, 70, so we'll put the 8 here, put the 6 here, 76 and 80, we'll put the 4 here, the 2 there, and then the 80 there. 52 and 72, 6, 4, 2, and 72. Well, let's see, we're going to have to move each one of these out. And then we'll put the 2 in right here. 62. So we'll put a 6 here, and put a 4 there, put a 2 there. 86 and 64. Put another 6 here and a 4 there. And it looks like we're done. Try to get the columns all lined up perfectly. I'd sometimes do a little better than other times. And then you're going to want a legend. So we're going to say 96 equals 9, 6. All right, you got to have a legend too. All right, good deal. Time series graph. A graph of the time series data, which are quantitative data that have been collected at different points in time, such as monthly or yearly. Features, it reveals information about trends over time. So let's see here. I don't know why I did that. I don't know why I did that. Let's see here, screen. I want my show taskbar. I wish I could get it to show taskbar all the time, but it used to. So let's go back to our calculator. And I went ahead and put some data in there. You see year in Manatee. Okay. I went to spreadsheet to do that. Then on, and then again, the graph. And let's see here. I'm going to put Manatee. What was the data? The data was year in Manatee. So let's put year down here. And we'll put Manatee over here. All right. And now we are making a time series. And there it goes again. We're making a time series. So we'll, we got to connect the dots. Menu, plot type, XY line. There you go. And that plots it or draws the lines. We good? Bar graphs. Bar graphs uses bars of equal width to show frequencies of categories of categorical or quantitative data. The bars may or may not be separated by small gaps. The features, it shows a relative distribution of categorical data so that it is easier to compare different categories. So a bar graph looks like this. Again, I put some data in there. I got boat and number here, and different. And these are like thefts during some year. I don't remember what year, but we want to press menu, data, summary plot, and then we've got our XY list is going to be the boat. Our Y list is going to be the number. We'll do number. Where's number at? Number. So our x-axis is boat, our y-axis is number, and we'll put it on a new page. And then voila. And if you'll notice, the calculator does it for you, and then it just kind of shows you. And notice how it puts the percents too, if you need those. The next one is Pareto charts. A bar graph for categorical data with the added stipulation that the bars are arranged in descending order from largest to smallest according to frequencies. So the bars decrease in height from left to right. Features, it shows the relative distribution of categorical data so that it is easier to compare the different categories. And it draws attention to more important categories. And same information before, I just rearranged it a little bit. And then again, we'll menu, data, summary plot, and then we got type on the X list and amount on it, and then we want a new page. Okay, and there you go, from largest to smallest. So if you were like a detective or something, and you realize that you might want to concentrate on the jet skis and the motorboats and not so much on the sailboats. All right. Pie charts, a graph that depicts the categorical data as slices of a circle, in which each slice is proportional to the frequency count for the category. Feature is it shows a distribution of categorical data in a commonly used format. And we can just go, we'll go right back to the data that we had here, and then menu, data, summary plot, type, amount. We'll do it on the new page. Okay, it looked just like it did before. And then menu, plot type, and then pie chart. And then there you go. And you can draw it right off the calculator. Frequency polygram uses line segments connected to points located directly above class midpoint values. Relative frequency polygram uses frequencies proportion to the percentages for the vertical scale. And what I would do is I would make a histogram using the calculator, make a histogram, and I'll show you making a histogram, and then just get it off of the histogram. And let's see here, doc, file, open document, and then we did, what was it, McDonald's lunch. We'll do that one. It's what we did before. And then say you just had this data here. You could go over here and you could say min, let's see, max, M, A, X, and then I guess let's put in AA. Variable not defined. What did I call that? It's AA, right? It's AA. So max AA. Let's see. Equals max let's go in there. There it goes. Max AA 308. And then min, let's see, equals M I N AA. All right, so, and then let's see, 308 minus 830. Let's see here. 308 minus, what was it, 83? Yes, 83, minus 83. And then let's see, let's divide that by 5. So we got 45. All right, not a problem. So now that we've got that data, let's see, control clear. Let's go. Well, you could actually leave it in there. It doesn't really matter. But we'll go on, and then we've got AA. Remember, it always defaults to the dot plot. And then we go menu, plot property, plot type. Let's change it to histogram. Okay, and then this doesn't look like it did, but we got to fix it. Menu, plot properties, histogram properties, histogram scale. Well, we'll do that one in a minute. Bin settings, equal bin width. And then, let's see, we decided on 50. And then we decided we'd start at 75. And then that'll size it down. You can also kind of like, and I have a hard time doing it like this, but you can spread it out a little bit like that. Anyway, so that's what it looks like. Now, how does this help you? Well, you see, you've got 11. Okay, so we've got 75, 11, that's what, 86. And then at 86, you got 125. And then, well, 86, I'm sorry, 75 to 125, that's 50, 25. So 111, and then 150 and 24, and then 210, and 250 and 3, and 302. And that gives you the points to plot on your graph. And I'll show you what I'm talking about. I'll show you what I'm talking about. So let's do this one right here. Let's see here. We're going to make us a frequency polygram real quick. And then, what did I say? What was my first one? It was 150. And then I had 200. Then I had 250. And then I had 300. Those were my midpoints, right? And let's see here. Let's see here. And then I think it was like, we'll say this is 5, 10, 15, 20, 25. And let's get that back. So we got 11, 24, 10, 3, and 2. 11, 24, 10, 3, and 2. So 5, 10, 11, 24, 11, 24, 10 is right there. 3, and then I guess right here we've got 350. No, that was supposed to have been 100. There's where I'm messing up. 100, 150, 200, 250, and then 300. So 11, 24, 10, 3, and 2, and then you just connect them. So here's your frequency polygram. And there you go. Easy peasy. Graphs that deceive, non-zero axis. A common deceptive graph involves using a vertical scale that starts at some value greater than 0 to exaggerate the differences between groups. Pictographs, drawing of objects, are often misleading. Artists can create false impressions that grossly distort differences by using simple principles of basic geometry. And we'll see some examples of that in class. Okay? Folks, you've been great. I will see you tomorrow in class, and have a good evening.